Welcome, everybody. And thanks again for the organizer to give me the slot after the lunch break. But anyway, yeah, the topic today is how to prevent your Kubernetes cluster from being hacked. So the aim is to share a little bit of projects, new project, and some ideas which could help you to prevent your cluster from being hacked. Yeah, I'm Nico Meisenzahl. I'm Cloud Solution Architect and head of our DevOps consulting operations team at White Duck. So basically helping our customers to get cloud native stuffs running mainly in Azure. Besides this, I'm Microsoft MVP, GitLab Hero, and yeah, integrated in the whole community around CNCF and cloud native topics. So before we start, I guess most of you are running Kubernetes. I guess. So who of you already thought about security in Kubernetes? And I hope we're seeing now, perfect. It's every time the same. I thought, okay, the security related conference, maybe we're seeing a little bit more hands, but yeah. So this is basically a common theme. This is a report from Red Hat from, I think it's last year or the end of last year, where they shared some numbers and basically, yeah, we still need to improve. So we have many issues related to misconfiguration, to security vulnerabilities, security incidents during runtime. So for me, at least pretty high numbers, and also talking about yeah, issues related to container and Kubernetes security, yeah, compliance issue, which lost to customer losses or revenue losses, is here up to more than 30%. So also, in my opinion, a very high number. Yeah, this is why I thought doing such kind of talks. Last year, maybe you heard of one of them. So it's pretty quite simple if you miss to implement some best practices to get access to a cluster, and you will find that talk, Hijack Kubernetes, on YouTube and all the information on GitHub. So it's basically how to get into the cluster, and today we're talking about how to prevent it. To do so, I'm a big fan of basically going smaller steps, doing best practices first, trying to get quick wins instead of thinking about a security project, thinking for it, I don't know, 2 years, and then after 2 years starting maybe implementing something. You could use the 2 years to at least get the easy stuff, easy things in place directly. So I'm a big fan of it, really thinking about the DevOps lifecycle, iterating and implementing the easy stuff, and maybe in parallel think about a big security guideline, a big project, but yeah, start with the easy things. Yeah, so things you should talk about, but we will not cover today, is basic stuff like, yeah, doing the quick wins I already mentioned, thinking not only about Kubernetes, also thinking about the applications. So make sure that your applications are secure, your deployment code follows best practices, and is deployed correctly. So nothing related to containers and Kubernetes at all, but very important. Then building secure and updated container images. Thinking about Kubernetes policies. Not only to prevent somebody in your company using your cluster to do things you don't like to have in place, but also if somebody is able to get into your cluster, you can really also build up railguards with policies for them. Same for network policies. I've seen so many Kubernetes clusters without network policies in place. If we talk about the on-premise world, DMZ and so on, everybody runs a firewall. So why not doing it in Kubernetes? Yeah, so just some easy examples, but today I would like to focus on 3 topics. So first one is we will have a look at Wolfie. Wolfie is an open source project from ChainGuard and helps us to build secure container images. Second one will be Cosign. So we will use Cosign to validate images and containers we're running our Kubernetes cluster. So think about, we would like to make sure that the Ingress Nginx controller we're just running is really the Ingress Nginx controller and not something else which, I don't know, mines some bitcoins or something. And last but not least, we will use Tetragon, Cilium Tetragon, to get some container runtime security, to validate the processes running our containers, seeing any kind of injection and stuff like this. So these are basically the 3 tools I will talk about the next, let's say, 25 minutes. And for all of them, we do a short intro, and then a short demo showing you some bits and pieces here. Yeah. So starting with Wolfie. As I said, it's an open source project by Changard, and Wolfie itself describes it the first Linux undistro designed for securing the software supply chain. So what the hell is undistro? Basically, it's a container image or a Linux distribution which is designed to run and to be used in cloud native environment. So basically, it only includes the things you need when running container. So there's no kernel in place. There's not a full-blown Linux distro into that. Basically, a V2 version of the distroless images you may know from Google. Also, some of the Google people are now working at ChainGuard and have implemented Wolfie here. So really, stripped down to the basis you need to run container with a very, very small and secure container Linux. Also, all the Wolfie base images you can use have built-in SBOM included at build time. So basically, if you use them, you don't need to scan them for any security vulnerabilities. You can just use the SBOMs they provided from build time and validate against them. And basically for everything included, which is really nice. All packages you're using is based on APK. You might know it from Alpine, for example. And all the packages provided by ChainGuard, by Wolfie, are designed to be independent. So basically, if you install, let's say, an Nginx, everything is in place. You just need to install one package. So they are completely independent from each other. And the really most important thing, at least for me, is the ecosystem around Wolfie. So there are a toolset I will show later, which helps you to fully define your container images and the build process completely declarative. So you don't have a Docker file where you're doing some bash things in there, but you have a YAML file describing declarative desired state you would like to have, and then the tooling to make sure that all the stuff is in place, which is pretty nice in my opinion. Yeah. So some Wolfie in action. What we'll do is we're building a base image or an image based on Wolfie, one of the Wolfie base image, and compare it against an existing image or an image we have built based on Debian or Ubuntu or something, compare the size, compare the vulnerabilities, and afterwards building a fully declarative image based on the Wolfie ecosystem with 2 tools called LPOK and Melange, which help us to build our application and then build the container. I also included some links here I would like to follow up later. So, perfect. That didn't work. Okay, here we go. So I'm doing just some copy-paste here, otherwise I will not finish in 25 minutes. So we have a sample Hello World application here. So it's basically just a Node application. We have a Docker file here. So as you know it, just copy-pasting the source over, doing npm install, and we're fine. So pretty common so far. So first thing we're doing is building that one, that we have building that one, just to show you that the application is running and working. So most of the things should be cached, so should be pretty fast. And now if we're running it fastly, just a curl here, and we should get a hello world. Woo, super. So this is basically the way you know it, I guess. Just building images. Yeah. Okay, so next thing, let's check for this image, which is based on Debian, which has Node packages on it, and so on. Just export it fastly to the file system, and then we can use any kind of tools to generate SBOM and analyze it. In my case, it's Sift and Cripe here. It's not so important, but basically, Sift will now scan all the layers of the images and create an SBOM JSON file on my local disk. And this JSON file we can now use Cripe to analyze and to get all our vulnerabilities. Just an example, so basic, I just want to show you the big list of security vulnerabilities we have in that image, which we have just built. So now, yeah, the database get updated, takes some seconds. And now we get a long, long list of CVEs, critical things, high things, a really, really long list of security issues in the image we just have built. So it's a really, really long list. This is basically where Wolfie can help us, because most of the stuff which is here unsecure and outdated are things we don't need to just run our applications. So if we strip down the whole image and remove all the stuff we don't need, we have a way smaller list of security issues here. And this is basically what Wolfie does or helps us with. So if we now build the same thing with Wolfie, just sharing the Docker file here, it's basically the same. Instead of the Debian node image, we're just using one from Jenguard. So they're building and updating images, base images we can use, and everything else is just the same. So if you now try that one and build this image, we can also run the application. Everything works as expected. Just doing that one here, running it again, and you see application is started, so everything is fine. So now we of course have to check the SBOM here and see if we have any security vulnerabilities. So I'm now skipping the application part, but most of the list I have shown you is anyway related to Debian here. So it's all Debian. Because we don't need, at least for the base image, to generate an SBOM. We can just download one from Jenguard. So they're providing the SBOM here for every version we're using. In our case, it's latest, so we don't need to provide one. So we can just use Cosign or any other tool to download the SBOM. Getting a short warning here, doesn't matter. And now we can use, once again, Cripe against this SBOM. And yes, of course, it's without the application, just the OS. But the list should be pretty small. So we have no security vulnerability. I think yesterday there was one. But hey, so instead of having, 250 vulnerabilities, we have 0. The application works the same. We have everything in place which the application needs. Just a stripped down, secure image which we can use. So really nice. Of course, but we will skip that for time reasons. We could now go ahead and use Wolfie or build the image, export it, and then scan it with the application. So there might be some dependencies in NPM or so. But the baseline here, the secure image is really, really safe. Also, if you compare the size, again, here we have the Wolfie. Oh, let me make this a little bit nicer. Yeah, okay, it doesn't work. But yeah, we have the original image here and the Wolfie image here. So also, of course, less stuff in the image. So, of course, also the image is, once again, smaller here. So this is just one part, which is nice, but I really, really like the tooling around. So first of all, I said we have two tools. We have Melange, and Melange helps us to build our application. So the outcome after running Melange is having an APK package which we can then put into our container image. And this is also declarative in YAML. So we're defining our environment, could be some packages we depend on, and then we have a pipeline section here where we can do anything. Yes, in this case, in this demo, it's once again, of course, the build process here, but you can define anything you would like to just build the package. Building is pretty easy. It's completely containerized, so you can use all the tools in containers. So what we're doing now is using nerdctl or Docker, doesn't matter, on a local machine, and just using the SDK image from Django in the first step to create some keys to sign the image, and then in the second part here, using the same image again with some build parameters to build our APK. So let's execute that one quickly. Oh, just getting some secrets here. Doesn't matter at all. The important thing is that we mention our Melange YAML here. And so now the tooling knows what to do. And building all the dependencies, building our application and package it together in an APK package. I already did that one, so it will end up basically here on our packages, and we have here our Hello World APK. It's already done. So now we have an APK, and next step would be to use the APKO tooling, similar UI, and this is basically our declarative Docker file. So we just say, hey, these are the packages, including our local one from our working directory, and then we define some permissions, we define a working environment, environment variables, entry point, and which account to use. Everything is declarative in a YAML file, no scripting, and so on. And yeah, with this information, we can basically then build our final image. And for example, in this case, once again, with the SDK version, providing our certificates here, providing the configuration YAML, and then define the outcome image name and where to store it. So basically, we will get a hello-world tar file in just some seconds. Okay. Anyway, I will show you in a sec because we will use that one later, or it's already done. So we have now here our hello-app tar file, which is our container image where we can now spin our instance, for example. Yeah, that one on the side of Wolfie. So pretty nice tooling, which can help you build secure small images declarative. So next one is cosign. So cosign is a tooling by Sigstore which helps us to sign OCI images or OCI containers or anything related to OCI. And you can integrate cosign also with your Kubernetes clusters. Why should you do it? You can then validate any images. So as I said earlier, you can then validate if where Incus Engine X is really the Incus Engine X. You can sign and validate your own image to really make sure that you know what is running in a cluster. And even better, there's a nice integration with, for example, Open Policy Agent Gatekeeper or Kyverno. We heard about both earlier. And those can help us to then enforce and check those signing and validation processes in our cluster. So what we will do, we will first deploy a policy to tell, so we will do it with Kyverno to tell our cluster and Kyverno, hey, it's only allowed certain images, certain keys, and then run an image which is already signed, a Wolfie image, and at the end, signing and running our own ones. Okay, let me close that one and going to the cosign. Okay, perfect. So first one is the policy we need. Yeah, so it's pretty easy. In this case, we're telling, so it's Kaverne policy, we have some rules, some matching kinds, and so on. And what we'll tell, the important thing is everything which is from the GitHub container registry and part of ChainGuard should be validated and should be validated against this configuration. In this case, it's used by cosign, the secretless option. So basically now our cluster will talk to the cosign infrastructure to validate the image, but in the second time we will also, second part, we will also show it with a public key here. But basically, yeah, we're starting with that one. So first thing is we need to apply the policy in our cluster. Then, doing kubectl get events in the second console. No, perfect. Yeah, anyway. And run any image here. In this case, it's one of the ChainGuard Nginx images. So completely secure Nginx environment. So running that one, it takes some seconds, and the pod is created. And okay, we're doing it now here again. If we now do a kubectl get events, we're getting here policy entry, policy applied, and the policy is passed. So basically, our Kubernetes cluster, our Kaverne, validated if the image is trusted, and it's basically the image we would like to get, said yes, everything is fine, and we were able to deploy it and to run it into our cluster. So basically, we can do the same with our own image. So this is basically the hello-aptar we just have built. Just loading that one into my local container registry and pushing it on my GitHub repo. A completely unsigned image, plain image here. Oh, let's do it a bit faster, please. Okay, next one is we will use cosign as tooling to generate a key pair, and then basically sign the image already stored in the container registry. This is this command here. Just doing the cosign generate. So now we need a password, and again. All right, please. So now we're basically signing, and the password again for the private key. And yes. So now it's pushes the signature also into my GitHub account next to my container image. And basically now we have to build the policy for that one. And as I said, in this case, we're telling once again any images from the container from GitHub in my account, and only with this public keys, or this public keys is trusted. Of course, we just created a public key. Just need to copy paste that one and change it here to make sure everything is working. Here we go. And applying that policy into our cluster. And it's reconfigured. And now running our Hello World application we have built earlier. And this one got also created. So let's check the events again. And here also the policy for check if image assigned for our pod default hello app got passed. So once again, basically Kaverne validated against our public key and made sure that we can trust that image and can directly use it. So really, really helpful for third-party images, but also for any of our internal images to validate that those are also trustable. Yeah. And with this, I would like to come to the last topic, and this is container runtime security with Tetragon. which in my opinion is also pretty important. So I will skip the what is Tetragon, how eBPF stuff works, because we have a workshop in the afternoon. Ray, in just 5 minutes, will talk about it. So I make this really short, just showing you some things. Basically, Tetragon helps you to get awareness into your cluster. So Tetragon can find any malicious, unwanted workload processes into your containers, anything running in your Kubernetes cluster you don't know. So basically giving you awareness and then also real-time enforce anything. So basically killing a process in a container or something else. And this is also what I would like to do. So basically we will inject into a pod by a log4shell. So it's a Java pod running all the Java version, and we will use log4shell here to get into the container as an example, and then basically block it with Tetragon to make sure that basically nobody is able to exit, even with the log4shell issue being in place. So to do so, first of all, we need to be here. And SSH, okay, one sec. So we'll not talk about log4shell in detail, but basically what we will need is we'll need to spin up an LDAP server, we need to spin up an HTTP server, and from there we basically getting a servlet which helps us to inject us into the pod. So first thing we will have to do is to start, and this is basically just a demo project here, starting the LDAP server we can talk to, and just open up a port with netcat here on any kind of Linux machine with a public IP address. So what we now can do is basically using this ContainerDays string, which just directs us to our virtual machine, that one, to the LDAP server we just started. And if we just copy paste that one and go to our application, our fancy application with a login screen, and pasting that one here and defining any kind of password, doesn't matter, blah, and pushing login, it's loading. If we go back, we're getting a connection from. So basically, I'm now doing an LS, for example, and this is the file system of the pod running in our Kubernetes cluster. So we're now in the pod, can do things, search for secrets, I don't know, going even further into the node, onto the cloud provider, doesn't matter. And this request, we're now trying to block it. So what do we have to do? First thing is, we need to apply a policy for Tetragon. And this one is a pretty easy one. So basically, we're telling with a tracing policy from Tetragon to kill everything which hasn't the PID 1. So basically, in a container, in the best world, we have just one process. So there shouldn't be a second process, so we're killing all processes after process 1. In our case, we just created a bash, or at least a shell, to access with log4shell, would be a second process, and this one would be killed completely. And this is what we're doing now. So we applying the policy. Here we go. Policy is created. And now we once again go to the machine. The LDAP server is still running. Just open up again the port on 443. Reloading the page here. And once again, copy paste the ContainerDays. And blah. Logging in. Now it's not loading. We're getting any kind of error, doesn't matter. And if we go back, we got the connection received. So there was a short connection, and then basically the session got ended because the process get killed. And we now could get even check the logs here with kubectl logs, and there's a Tetra CLI, which is a little bit nicer. Oh, sorry, wrong shell. And now we're seeing all the information. We're seeing the syscalls here, and we're seeing it exits and being killed by Tetragon. So killing is one option, but also just getting the information that there was a process is really helpful. In our case, we decided to really kill it, and this is being directly after the process got started. And it's really just the process, it's not the whole pod. It's really only the process we don't like to have in our cluster. And this is really, really helpful to really get a secure Kubernetes cluster. Yeah. And with this, I'm at the end. As I said, it should be just an introduction to some tooling, some newer open source tools out there which can help you to further secure your Kubernetes cluster. All slides, as well as the demos, are available on GitHub and slide deck, SlideShare. So, yeah. Thanks.
As usual, questions?
Everyone has fallen asleep.
It's a tough session after lunch.
Thank you.
But you did great, It's so good.
Yep.
Nico, could you tell me what's this NerdCTL tool which you are used?
Oh, it's just a CLI for ContainerD. So basically, I'm running Rancher desktop with ContainerD, and NerdCTL is just the Docker CLI for ContainerD. It's basically the same commands.